Ooh, why? All right. Hello, everyone. Really glad to be here again this year. I'm here to tell you a little bit about our cross-chain wandering adventure, me at Cometh, and all the different people that we work with, and also to present something that we were cooking for the past year called SKUL, Slim Keystore Utility Layer. So first off, thank you for coming to my talk. I'll be hosting the Ethereum Community Conference, ECC, in Cannes in a few weeks. I hope to see you all over there. And if you want to chat, if you want to reach out, I'm easy to find, always using the same handle, at g.tychey, like this. Okay, so just one quick word about what we do. We have an account abstraction SDK for heavy-duty apps mostly. We do a lot of R&D on passkeys. We implemented a few verification of the curve in Solidity. We participated in various things on that front. We also work on social keys, on cross-chain stuff. You can find all about there. And we also are a custodian registered in France. So if you're looking for a compliant MiCA DeFi infrastructure, reach out. We have a lot of cool things to talk about. And we run a white-labeled optimization for Treasury with Monerium called Louis.finance, if you want to check it out. Okay, so here is the plan for today. We're going to discuss those 4 points. So AA and chain abstraction, account abstraction in production right now, and going multi-chain. And finally, a small contribution to going for better multi-chain with SKUL. Here we go. So this is where we stand. Personally, me and us at Cometh, we are in a world of abundance of block space, and we have a lot of challenges to tackle. So what we think when we look at the damn! Now I had a few cool memes inserted that was missed in the update of the slides. Well, never mind. We believe in safe, like smart account for everyone. We believe this is the right way to onboard and to run applications. We believe in passkeys because they are already available in every devices that the user will use. But passkeys to sign and not to log in on a third-party service for accessing a signer, I think it's much cleaner to use passkeys this way. But to be honest, the current status is that smart accounts in a multi-chain context, with fragmentation of the experience, with fragmentation of the liquidity, is a bit hard. It's a bit harming the UX, and it's also a bit slowing down the AA adoption, unfortunately. But it gives rises to new challenges that we are happy to tackle. Here we go. So in terms of fragmentation, we already have 158 mainnet layers that are listed on L2Bit. A lot of more that are going to be released, a lot more that are not listed because they don't list themselves. We have countless EVM everywhere, and we have this topic of use cases and complexity of reading state, of reading information from one layer to the next that have been discussed since 2022, 2023, and we know it's a complicated topic, and we are kind of ignoring it, in my opinion, even if we just had a pretty good presentation from the guys at Colibri, Stephen Cox, that's really inspiring in what the thing we can do right now. So here is a couple of takes that I'm happy to debate with you over lunch or in the question session of this talk. A few hard to swallow pills. First, the EOAs really do not work. For accounts, for the average Jane and the average Joe, they barely work as signer. People lose their key, people don't understand the security model. It takes a lot of time to make them evolve toward this. It's also much easier for the Web3 guy to go fund his smart account, that he already has some Web3 knowledge, he already has some funds on an account. It's much easier for this guy to fund his smart account than it is for the Web2 user to use anything but account abstraction, actually. So if you are thinking about retail adoption, if you're building a retail app, keep that to yourself. If you're not doing account abstraction first and not thinking the experience around account abstraction, you're probably fooling yourself in the addressable market and in your customer acquisition cost. Are we in a state of disillusion right now in account abstraction? So it's kind of hard to get good data on account abstraction because not all account abstraction implementation are 4337 compliant. There is a lot of work done at Bundlebee here, but the data are a bit messed up with some big actors like WorldChain and WorldApp that have arguably a few millions of users. So maybe we can say that 80% of the account with one user ops are coming from WorldApp. If you take a few one-hit wonder, a few scam and so on, you end up with roughly, I think in my opinion, less than 4, maybe 5 million users with all the legacy safes as well. So yeah, we're still not there in terms of account abstraction adoption. And one of the reasons why we are still not there is that there is a perceived complexity that's kind of hard to overcome. We had a lot of debate on which smart account standard to use. Even if we had safe for all of this time, yeah, it's better to rebuild my own smart account because I'll go faster with this. 4337 had a few updates, it moved a lot. There is a perceived complexity behind this as well. And once you start to implement account abstraction as the default accounting method in your application, there's likely no way back. Like you are into account abstraction and you have to embrace it. So a lot of the large application in our industry have considered like an abstraction and said like, hey, it's not mature, let's build my own wallet. Yeah, it's not mature, let's use a wallet as a service. So it's kind of hard to piggyback for the DeFi applications and help kickstart the account abstraction adoption this way. Because they are busy fighting for TVL, and Web2 users have proven to be very expensive to grab in their user base. So what are the pioneers doing? What are the successful apps in account abstraction doing right now? So you have Metri here with the Circles implementation. So try it out at this conference if you haven't had your Metri account already. It's smooth, it's beautiful, it's working, and it shows how account abstraction can work at scale. Another example is Polymarket. They use safe, they use proxy account. So when you go on Polymarket, you just create a safe and use a safe. It's not directly showing into the data of 4337 because it's not using 4337, but still, it's account abstraction. And of course, in terms of number of users and usage on the chain, you have to mention WorldApp. So here is the problem that is looming, the don't look up aspect of account abstraction. Here is Bob. Bob is a Web3 curious. Bob's just onboarded seamlessly with account abstraction on Circles with Metri. Yay, Bob is here now. Yeah, hey to Bob, thank you for coming to Circles. I'm going to trust you, you're going to trust me back, and we are going to action some CLC. Bob's transactions are sponsored. He doesn't have to pay any money to do any transaction. It's great. The experience is smooth. He's on Noz's chain. He likes the aspect of it, and he clicks on copy my address. So now he knows his address. It turns out that Bob had an old account on Binance because he met a friend that told him like, hey, crypto is great. You should buy $10 of it. And now he wants to withdraw his ETH from Binance to the mainnet or the Binance Smart Chain on his smart account. And then Bob rushes to the Discord, asks for help because his balance is not showing, of course. So we experienced this firsthand at Cometh with one of the games we were powering, Cosmic Battle, with over 100K players. And we had this a lot, people coming up like, hey, where is my balance? I just withdraw on Optimism. Yeah, but the game is running on an L3 on top of Arbitrum, so yeah, it's not showing. And solving this kind of problem is really complex. Last year at DappCon, I had a talk with the Ghost Step with, from Frontier Research, talking about the cake layer. So you have the application layer, you have the permissioning layer, you have the solver layer, you have the settlement layer. This is what you need to consider when you are thinking about cross-chain. Cross-chain communication, gas abstraction, of course, liquidity unification around what you want to do between chains, inter-blockchain communication as well, and aggregating DeFi stuff. Encompassing all of those problems, you have a few tryouts in the industry, notably particle network, eigenlayer, and so on. And most of those applications are trying to encapsulate this complexity and expose good endpoints to tackle that. But it doesn't really translate directly into account abstraction, unfortunately. So we were lucky to have one of our tryouts being funded by Gnosis Guild. We used the resource lock module to expose this kind of cake approach for multi-chain, cross-chain interactions via the resource lock. It was good, it's working. You can use the resource lock module to say, hey, I want to have ETH on Arbitrum, and I have ETH on Optimism. So let me lock up the ETH on Optimism, create an intent that I want to receive the ETH on Optimism, on Arbitrum, and if you fulfill this intent, you're going to get the money out. This is cool, but this is not super duper scalable because it's more of a push model than a pull model. And thus, it creates some discrepancies in the UX. So this is what has been driving our R&D, trying to bring the control of your smart account everywhere for everything and all at once. And one of the problems that it brings up is how to properly read across L2s, how to properly prove that something happened between layers. And this is why we love the thing that Colibri is doing on that front. So one of our achievements for last year was to try to think about this problem at a larger scale, thinking about how we could potentially index on an application layer the whole history of all participating chains. So storing the block headers of any layers of any blockchains and trying to prove recursively through hash trees the inclusion of specific transaction, the particular storage at a particular state for a particular account, and so on. And well, unfortunately, it was kind of hard to rally people around this idea and to find funding to continue this kind of R&D. But we are keeping that on the stove, waiting for it to be mature enough for the industry to kind of adopt this kind of approach. And by Pectra, we had 2939 that gave us a lot of access to historical information in the block hashes. So there are still things to do regarding this kind of multi-chain indexing and industry proving. We tried to implement that as a safe module, just so that we would have a primary, secondary, or a master-slave relationship between safe, like relying on Hashi notably to pass the messages across multiple different oracles and arbitrary message buses. So you have a message that you want to convey on chain B, you have a safe on chain B, but your safe is being activated from chain A. We managed to implement something that was kind of not even a prototype, but kind of a proof of concept. And we really wanted to be pushing forward towards having a pool module. Like you're on chain B, you want to do something, you have funds on chain A, just do something and get that running. So that brought us to the approach of SKUL here. So a slim Keystore utility layer, like a small module for every smart account that you can easily rely on, that allows you to manipulate your funds on any chain that your smart account is deployed on from a reference chain where the SKUL is deployed for your smart account. So as it's been kind of hard so far to bring up this big idea of having all the different EVM flavors indexed at the same place so we can have these proofs that we can carry over to any chains that we need to, we're trying to do a smaller step. Let's do that as just a small module that you can put on any smart account. Here are a few design rationale for that. We rely on storage proof. So we had a question before on the overhead of the proof on the talk about Colibri. Storage proof typically give you an overhead of 250,000 gas, which is what you need to prove that a specific transaction, a specific state was actually included in the reference chain, so you can trust it. We believe that current effort about ZK proving the EVM will ultimately lower that and accelerate this kind of adoption. We may have some opcode optimization at some point, so for proof validation it will likely accelerate. So that's likely your highest threshold here. The trust model for this kind of approach is typically the trust model that you have on the reference chain. The worst cases are some delays. Arguably, there can be some reorganization if you deploy on the L1. Sometimes you have blocks that are reorgs. But yeah, the worst case is mostly delays, in our opinion, but happy to discuss this kind of trust model later on. And you need to rely on an arbitrary message buses. So from our perspective, those tools are kind of mature right now and available for production. They are available for multiple DeFi applications that are relying on them to do cross-chain stuff. Chainlink and USDC across chain are a good example of that. And the readiness is here. It's ready. It's ready for 43.7 smart accounts, and it's also ready for 75.79. So from an L1 to N2 standpoint, you have access regularly to the state root infos. Well, every time the L2 sequence in the L1, you have exchange of information, so you can recursively do these proofs. Regarding L2 to L2, it's a bit more tricky, but there are ways to do it, and this is why we thought initially that a layer to index everything and to create those proofs would have been pretty cool as well. So here's what it looks like. You have Bob on chain B is looking at swapping ETH to USDC. He has a safe on chain A. Or a smart account on chain A. He's multiple owner. He's one of the owner and is a big enough owner to actually trigger a transaction. The safe on chain A does have this SKUL module implemented, and you have some off-chain services that will generate the proof and pass the proof. So for Bob's interaction on chain B, just swapping ETH to USDC, Bob's is creating this intent that will be a user op on chain B, like any user op, except that you have an extra information about the storage proof that Bob's wants to do that and is allowed to do that. And voila, Bob can now pull the information from chain A and do something on chain B. So we go to on-demand action for cross-chain of smart account interactions. And yeah. This is it for today. I'm happy to take some questions. If you want to read more about SKUL and its implementation, here is a link to a Medium post by Frédéric de Matos, Johan Salver, and Vincent Le Gallic that shows how it's implemented, give you more detail about SKUL and why we went this direction. And the code is, of course, available for you to check out. It was freshly published 2 weeks ago. We think it's hard and ready for production, but challenge us, please. We'll be happy to answer and improve the model with you guys. Thank you for your attention.
Thank you, Jerome. And we have a few moments, maybe actually one question. Up here.
Damn, it's hot.
Thank you for the talk. I wanted to ask, you mentioned that the worst case, in case of like reorganizations, would be delays. But how is that the case? How is the case that you don't need to wait for instance, roll-up chain finality to make these transactions?
Yeah. So regarding reorgs, yeah, you should take into consideration that as a solver, as a cross-chain actors, before you take an intent, you need to trust that the intent will be fulfilled normally. So typically, if you look at $1 million being moved from one chain to the other, you may want to wait a few blocks before saying like, hey, this is a good enough reference block. This block has I don't know 10 blocks of age, so there's very unlikely that this will be delayed and reorged. Sorry, and so I can trust this one. So typically what we recommend is that before you interpret a storage proof as a reference proof that you can act on, you should wait a little bit that the storage proof is actually showing from a block that is old enough from your security considerations. Nevertheless, when it comes to the L2s, well, you do have to take into consideration that not all the L2s are the same in terms of fraud proving and potential centralization points. So yeah, do your own research regarding the L2 that you consider. But when let's say Base is sequencing into the L1, you you can more or less take it for granted that what Base just wrote in the L1 is here to stay, and that Base won't change its state to something else because they decided to reorg massively and go back from the previous state that they previously sequenced. So there's definitely some consideration to take here in terms of security, but overall, the ZK-ification, the ZK proving of the EVM, all the effort that are going into this direction will give us much more clarity and much more security regarding the cross-chain communication overall. But that doesn't mean that this kind of approach won't just adapt to the new state when we get ZK proof everywhere.